we're going to be talking about the differentiation using these four formulas, so to speak. And we're going to use some of the examples to illustrate how we can make use of these. So we start off with the original function, y equals to a product of two things. So obviously we're using the product rule here. Now when you see this one, don't confuse it with polynomial. It's not a polynomial because the x is not here, it's on the index. So we are going to use this one here. Now if you first treat this as a function of x, then we call this u. To differentiate 3 to the power of u, first of all, the a is a constant greater than 0 and it's not equals to 1. So that's basically rewrite this whole thing here. Then followed by ln of a, that is ln of 3 in this case, and it's just a constant. And then because this is a u, not just x, then we have to follow this with the du dx. Okay, it's a chain rule. And so this is 1 over 2. That's how we do it. And so we're done on this part. Now this part is an exponential with the base of e. Then we'll use this one. And it's even much easier because the derivative of e to the power of x is the same thing times du dx with the chain rule. And because u is just 2x, this small function, and du dx obviously is just 2. And so we're also done with this part. Then it's just a matter of simplification. Okay, then we see there are some common factors. This one and also this one. So then we move them out here to factorize, then this is the answer. Now for this example, we're going to differentiate this one with respect to x. Okay, so we start out with the original function, and obviously you see that it's a fraction, so you must use a quotient rule. Now the only part that's new is differentiating this part, and because it's ln, then we're going to use this one. Now it's actually quite easy. The derivative of ln of x is actually just 1 over this. Of course, given the condition that x must be greater than 0. And so when we differentiate ln of u a function of x, then it's just 1 over u times du dx. Again, the chain rule. And so when I differentiate this, okay, I would just write 1 over whatever the u is times du dx. In this case, it's just 4. And so back to our question here. So after differentiation, this part equals to this part, and this part becomes a 10x. Now let me move this up here a little bit. But how do we simplify? Now first of all, we're not breaking this product. But the problem is we don't like a fraction in a fraction. This is a fraction on the numerator, and we don't like that. So the way to do this is to separate this whole thing into 2 terms. Now I could cancel out these 2. And this will be our final answer. And remember, for the denominator, we don't need to expand it. Now that previous example, we used this one. It was just a log with base of e, and that's what we call ln. Now we consider differentiating a function with another base. Okay, so in this case, log base 8. To understand or memorize this better, let's start with this one. The derivative of ln u equals to 1 over u times the du dx. Now, ln is just the log with base of e. Now, if I change the base, I will have to add another constant here. So if I have a base 8 here, I will have this extra constant here. So back to our original function. First of all, of course, this is a log, so we move the index to the front. Now we could differentiate this whole thing, with 6x plus 7 being the derivative of this. And so this will be the answer.